Hello, I received a question today about measuring alpha frequency, the peak frequency, and also to map it. And I said, well, that's an opportunity to show several of the frequency analysis tools in Persyst they can use for all sorts of applications, not just this, and show that there's multiple ways to measure frequency in Persyst and to map it. So without further ado, we'll go ahead and open up a recording and just run through the process so you can see what's available. My name is Michael Guest, VP of Research and Clinical Applications for Persyst. And I just opened the database. This allows you to set one or more file locations of one or more different file formats. You can do multiple file formats at once, and then have it index the files so you're not selecting them by browsing through the file explorer. You can actually bring up a list of patient recordings and click on them. These are training recordings, or part of our EEG teaching library. I'm just going to open up a 24-hour record. So I have different patient states in this particular recording. I'm showing 15-second EEG page, and right now we're set at 7 microvolts. We're looking at an average reference montage, and the reason for doing that is we're going to be doing some mapping, but you can certainly use any montage you like. But I'm going to leave this in an average reference montage. Turn off our artifact reduction for the moment so we can see the effects of that. And right now we're showing a low frequency filter of 1 hertz. That is a preference. By default, Persyst will start out showing time constant, so a 1 hertz filter would be 0.16 seconds. But the current convention, of course, is using frequency for low and high filters. So by selecting that under the preferences and general preferences, 1 to 70 hertz, Burger Band EEG, and let's find some alpha. So to do that, I'm going to split the screen, and I'm going to move some of these boxes out of the way because they take up a little bit of space. But now they're just tabs. In a review, normally you'd have them tabbed out of the way if you weren't using them. And we have artifact reduction now. If you can see how noisy the trends are. In fact, we have a bad electrode here. So when I turn on artifact reduction, then what happens is that goes away. Or it's separated from the cerebral signal. And it makes it easy to find what I'm looking for. So as I page around, I'm looking for alpha for this example. And this rhythmicity spectrogram does a rather nice job of showing that. So this shows rhythmicity for the left hemisphere. That's what's selected by default. Of course, you can use different channel pairs or different channel sets. And rhythmicity spectrogram, right hemisphere, 1 to 25 hertz. Here's the scaling. And just like gain on an EEG, you can change gain on spectrograms. So as I turn this up and down, setting the threshold, the color range that's being used. And I can set that so things are nicely visible. The default actually works very well because right here I can see I've got rhythmic activity, and I can zoom in a little further. We're looking at 1 hour. Let's go to 30 minutes on the trend. So it's bilateral, is rhythmic, it's not evolving, it's alpha. And the way we're scaled here on the right, 1, 5, 15, and 25. The lower part of this is expanded. So first measurement option is I can right click on that vertical scale and show values. And here you can say at this point for the trend it's showing 9.9 hertz for both left and right. So that's one way you can measure alphas. You can just go to it in the trends and you can drop a cursor and right click and show values. Method 2 is you can actually do some measurements on the EEG page itself. So right now we're in split screen. Of course, trends shows full page trends. EEG shows full page EEG. Let's go ahead and use the measurement tool here. So if I click Tools and Quick Stats, I can drag a box around a waveform, and it'll give me the predominant frequency here is 9.92 hertz, and also I get the duration. I dragged the box around 5.546 seconds, so I get the peak-to-peak values, as well as the maximum vertical and maximum vertical positive and negative excursion and all that. So there's a measurement. Now if I want to do additional measurements, I can hold down the control key, select tools, and then if I go to quick stats again, well, I can leave the measurement boxes up and continue to drag boxes around the EEG. So again, tools, quick stats, and drag a box. And then if I want to do additional ones, hold down that control key. Now, something to be aware of, if I click off of this, if I'm not using that quick stats tool, I can just click and hold and move the EEG this way. So If you go to click on the EEG and drag, well, you're dragging the EEG. If you want to measure it, use that quick stats. So that's the second way of measuring frequency. Let's go into a little bit further. So if we go to Tools and Insight 2, it's going to launch another user interface, same programs. We've gone to the same part of the EEG. And this is Persyst 14, but this is using the Insight 2 interface, which has more buttons. And drag and drop them around and give us a little more room. And these can be repositioned, but what this provides is additional set of tools. So let's go ahead and show the comment list as the first part of this, and I'm going to resize this to show it in a little bit different spot. Because what I want to do is I'm going to place a range on the EEG, and to do that I'll just click where I want that range to start, go to Insert, select Cancel Range, and we can go, we'll go about 14 seconds of EEG. Now the reason I mark this is I want to then go ahead and then use that comment, save the comment in the recording. So if I want to come back here and look at what I measured and repeat that measurement, it'll save this as a duration comment, and I can use that to define what I'm going to do for measurements within this. So Insert, I'm going to do Add Comment, and I'm just going to call this at, so that it's the top of an alphabetized list, range 1. You can call it whatever you like, but I'm going to call this range 1. And there it is. So what can I do next? Is I can go ahead and I've already got an average 12. If you use a bipolar, that's fine. You can do measurements with that. But mapping, you want to use some sort of referential montage so that they're all being compared to, you know, one value as opposed to, well, we won't get into why bipolar doesn't work for mapping. But in the meantime, one way to do it is I can right-click, insert vertical adornment, and pick frequency domain analysis. There's other tools here as well, but we're just going to stick to that. There's a whole application note that talks about all the other tools under the right-click menu. There's the alpha there, but how do I know what range I'm looking at on the EEG? So I'll right-click, go to Properties, and this opens up a lot of options here. We're already set to Power Spectrum, and we're going to do data ranges. Instead of the whole page, I'm going to say Events is Ranges, and Selected, and click OK. Because when I select this range, that tells this to do the FFT analysis on this range of EEG that I've marked this range 1. And I can have more than one that I select. I can multiple select stuff as well. Okay, so let's go ahead, and I'm just going to move that out of the way for the moment. I'm going to right-click and go to Properties again, and I can define frequency bins, delta, theta, alpha, beta. I could load them from a file. So the first thing is I do bin analysis, and I can either create my own frequency bins by typing them in. I could load them from a file, and under Program Data Persist, so if I go to this PC, C drive, Program Data Persist, Program Data is where Windows settings for programs that run on Windows will typically save their preferences. So Program Data Persist, and FDA bins, frequency domain analysis bins.xml. So you can create your own bins and save them, but these are already defined. So now I have my delta, theta, alpha, beta, and click OK, and you can see it's marked these off on this display. So what can we do with this then? Is I can right-click on this, insert a vertical adornment, and put in a table of values. And so I can move this over a bit because, again, I've already told it to use. Here's my comment list. I'm using range 1, so even if I'm making that EEG window a bit smaller, it's not going to change this, what's being measured. So I'm going to move this over a little bit so I can size things the way I like. And I'm showing average and sum amp, but what I really want is something different. So I'm going to right-click on this and click Properties, and I want the peak frequency and the average amplitude, let's say. So you can pick either the average amplitude or power within the bin, or you can calculate the area under the curve within that bin. But let's just pick these two and see what we get. Click OK. So now per band, I've got delta, theta, alpha, beta. The other one's a little bit off the screen. I can right-click and copy this table to the clipboard and drop it into a spreadsheet or what have you. So, or I can just move this over a little bit so we can see more of those columns. But that answers the question of how do I get that peak frequency. There it is in the alpha band per channel, 10.2 hertz pretty much throughout for the predominant frequency there within this band. And you can see those peaks line up very well there. Now if I don't want to look at these other bins, I could do that. I could right click on properties, and let's say I want to get rid of delta. I just click on it, delete, and now I'm only looking at theta, alpha, and beta. So the bin analysis says create these bins, and then when I insert a vertical endowment, I create that table. It creates this table of values. Now, how do I do mapping of this? All right, so I'm going to go back to properties on this table, and I don't need that peak frequency anymore. I've got that. I'm just going to take the amplitude, select OK, and now I've got the values for theta, alpha, and beta. And if I right-click and insert a vertical adornment and select the topograph, maps show up for that. And you can see that some these look a little strange. So let's go ahead and fix that up. I'm going to click Properties, and we'll go ahead and go to the color. I'm going to change this to blue, white, red. And the topograph, we'll go ahead and show the electrodes and see what that looks like. So that looks a little better. I'm going to get rid of beta because, again, we've got this very high amplitude for alpha frequency, but the other ones are much lower. And it's auto-scaling. I could turn off the auto-scaling by going to Properties and going to Color, and I could turn off the auto-scaling here. Or I could actually go to Properties on this graph and remove the theta, because, again, the question was, well, how can I map the alpha? Well, I've gotten rid of the other bands, click OK, and now I've got a map of the alpha frequencies using an average 12 longitudinal montage, and you can see the amplitude is highest on the occipital channels, as one would expect. So that's how you do that. Now I can even show these values on the map. So if I go to Properties and I go to Topograph, I can show the values instead of the channel labels. There they are. So this is a lot of clicking. So what do you do? Do I have to do that every time I do a measurement? No, you can actually go to Montage and do Save Adornment Montage, and I'm going to call this Alpha Map. So once that's done, it becomes available from this drop-down list. So there's my Alpha Map. I can click NA from that list. It gets rid of it. There's some ones that are pre-built. Here's a FFT, Delta, Theta, Alpha, Beta map. And set up with the properties that I had selected before. So I'll go to Properties, Topograph, and let's say I don't want those values there. I just want the electrodes. I could change the color scheme. So whatever you right-click on, it's going to open up a map, or a dialog box rather, appropriate to that. So those are several ways to measure frequency in Persyst. Any questions? I'll be happy to connect by web conference. Went through this fairly quickly, but I thought I'd show multiple different ways of getting these values. And to answer specific questions, I'll be happy to meet by web conference. This is Michael Guest, VP of Research and Clinical Applications for Persyst. Have a great day.